The title of this topic may sound a little strange. But unfortunately, the topic is completely underrated. The light of the sun has a limited range. The atmosphere has a very large influence on this. Unfortunately, we don't learn anything about this anymore today. In the heliocentric worldview, sunlight is supposed to travel millions of kilometers through the vacuum of space to reach us. When you compare this with what you can discover in old books, there is a huge gap between then and now. The ether used to be common knowledge. Today it is kept secret from us. Just like the massive firmament above us. When Alex Gleason created his map, he probably had very detailed knowledge of the distribution of light within the firmament. The two graphics in the lower corners of his map of the sun's path say a lot, especially the statement that it always remains dark beyond 80 degrees south latitude. And this statement does not fit at all with the false globe model of our Earth. Because there the south would have to be symmetrical with the north. However, Gleason created a third graphic for the equinox, when the sun is directly above the equator. It can be found in the second part of his book. It is an observable property of the atmosphere that the distance to the zenith of sunrise changes very significantly from north to south in different months. Alex Gleason also wrote about the spread of sunlight in his book and pointed out a greater range to the east and west. It is also remarkable what else can be found in old books. The ether as a medium. The medium that transmits our sunlight. And in which the lights known as planets move. The idea came to me when I read the following in G. P. Quackenbos' Natural Philosophy, a chapter on optics, under Division of Bodies. No substance transmits light without intercepting some of it. It is calculated that the sun's rays lose almost a quarter of their luminosity when they penetrate the Earth's atmosphere, and that if this atmosphere, 45 miles, extended 15 times as far from the surface as it does, we would receive no light from the sun at all, but would be plunged into eternal night. Well, light penetrates a thinner body further than a denser one. It also penetrates more transparent bodies more easily than less transparent ones. Storms refine and purify the atmosphere, heat expands it, and cold condenses it. The southern atmosphere is more transparent than the northern one. The tropical or equatorial atmosphere is more expansive and less dense than the Arctic atmosphere. The rays of the sun extend farther east of its center or core, directly below its path in the sky, than in any other direction. With these facts in mind, the diagrams will be well understood. Interesting, what he wrote about the storms. What are these southern wind zones called? The roaring 40s, 40 to 50 degrees south. The wild 50s, 50 to 60 degrees. And the screaming 60s, 60 to 70 degrees. That would be a logical conclusion as to what causes these day lengths. To show this, I compared two locations at the solstice. Manicones in Newfoundland, Canada. And Cape Horn. In Manicones, on June 21st, the sun is 6,560 kilometers away at sunrise. On December 21st, the distance is 6,816 kilometers. In other words, it is farther away from the zenith of the sun. This becomes even clearer when looking at Cape Horn. While the sun is on the northern tropic, the distance here is 8,487 kilometers. That is more than in Manicones at sunrise. The distance then increases in December to 16,755 kilometers, which is almost double. The closer the sun gets to the firmament, the greater the range of its light in an easterly, or westerly, direction. That sounds illogical. The sun should actually illuminate a circular area. Gleason's explanation of further propagation in easterly and westerly directions due to the influence of the atmosphere seems to be absolutely correct. The same time data can also be found in the daily pages of the Nautical Almanac. which Gleason had confirmed by the CEO of the Nautical Almanac and as he wrote in his book. The ether as a medium and the firmament are part of this mystery, whereby I imagine that the firmament cools the atmosphere at the edge, thus favoring storms in southern regions. Add to this the sun, whose speed is much faster at the further southern latitudes, thus creating a greater temperature change between warm and cold. To the north and south, the range of sunlight and all other celestial bodies is limited to 90 degrees of latitude, which corresponds to 6,376 kilometers. This is important for determining latitude, and only works on a flat Earth. When the sun is at its zenith on the meridian where you are located, it reaches its highest angle of elevation. Since the sun moves between the tropics, you have to calculate the distance to its zenith point. 90 degrees, minus the measured angle of inclination corresponds to the distance from your own location to the current latitude of the sun. In the case of Polaris, which changes its position only minimally, the angle of inclination corresponds to the latitude of your own location. However, the angle of inclination determined with the sextant must still be corrected for atmospheric refraction in order to obtain an exact calculation. The altitude above sea level. Temperature. Air pressure. This procedure is the same for all celestial bodies. This means that all lights above us are at the same altitude. If they were at different altitudes, a separate calculation method would be required for each object. The entire starry sky can therefore be compared to a flat room ceiling that revolves around the North Star in the center. This is how my astro compass table calculates and displays the respective zenith position on the map. The data corresponds to that of the Nautical Almanac, which lists 57 stars. These are the brightest stars from different constellations. The calculation is performed by entering the date and UTC time. When you enter the time zone, you get the current local time of the calculated location. The compass bearing angle from the location to the zenith of the star is also calculated. This is the sun table. The function is the same. However, it also exists for the moon and the wandering stars known as planets. I would like to continue exploring the mystery with another example in two locations. On December 21st, at 18 minutes and 39 seconds, the sun crosses the meridian of Auckland. It can then be seen in the north at an angle of elevation of about 77 degrees. At the same time, according to time and date, the sun appears in Perth in a slightly southeasterly direction, 96 degrees east, at an altitude of 38 degrees. However, the direction to the zenith point of the sun is 56.95 degrees east. The red arrow points to 96 degrees east as seen from Perth as the perceived direction to the sun. This should prove that the entire atmosphere plays a role in the perception of all celestial bodies. The same effects also apply to the light of the stars and the moon, which, due to the higher speeds at southern latitudes, should not be visible in the sky for as long. Is this also the secret of the circular star trails in the southern sky? First, a star trail recorded in Germany, heading north. This originates from Australia, towards the south. However, as we have seen, all stars revolve around the North Star. This can only be explained by what I am attempting to describe as the influence of the atmosphere. Since one looks south toward the firmament from all locations in the south, and this optical phenomenon can be observed everywhere there when night has fallen, the southern celestial pole cannot exist. This is a legend intended to justify the globe model. On a globe, it would be theoretically possible, but we know that the Earth is flat.